Hello everyone. Today we are going to solve the problem minimizing coins from CSES problem set. So consider a money system consisting of n coins. Each coin has a positive integer value. Your task is to produce a sum of money x using the available coins in such a way that the number of coins is minimum. Okay, so you have to construct money. You have to construct money x. You have coins, suppose C1, C2, C3, and so on. And you have to use minimum coins, minimum number of coins. Okay, you have to use minimum number of coins. So for example, let's take 11. For 11, and you have the number of coins 1. So you can take 11 times 1 to make 11. You can take 2 times 5 and 1. You can take 7 and 4 times 1. So you are using 11 coins, you are using 3 coins, you are using here 4, 1 plus 5 coins. But the minimum number of coins you are using is 3, right? So the answer is 3. Now, first you have to think what is the smallest problem that you can solve. Think about it. What is the smallest problem that you can solve? Yes, you can solve the problem 0 that you have to construct some 0 by using the coins. So you definitely do not going to take any coin to construct one. So for this answer is 0. That you cannot take any number of coins. So for F0, the answer is 0. Now tell me for 1. How many number of coins you are going to use to construct one? I am force you to do with using previous result. That you are using the previous states, that is F0, to construct one. So if you are using 1, then next you are going to construct 0. That is using coin 1, right? That is using coin 1. If you are using coin 1, then next target you have to solve is sum minus coin. Next target is going to construct is what are the minimum number of coins to construct sum minus coin, right? So this is the sub problem that you are already solved, or you can see, you can also say that this is the previous result that you are already solved. That is the previous problem that you are already solved. So I can say that many times you have to construct this. So there can be sub problems. We can see that when we construct 11, right? So for F0, the minimum number of coins is 0. For 1, you are using 1, right? So you are adding 1, that you are using the coin 1, right? This is not the value of the coin, this is the number of coin. This is the number of coin, not the value. Okay. So for F1, the answer is 1, right? So let me do similar procedure with the 2 and give me the answer. So for 2, you can you have coins 1, 5, and 7. For 2, you are going to use mm, one coin 1, because 5 and 7 are greater. So you are not going to consider these coins or use these coins to construct 2, because this never helps you to construct 2. So you can take the coin 1. If you are taking the coin 1, next you are going to construct is 1, and you are using coin 1, you have to add up 1. So for 2 F1, you have already calculated the number of coins to construct F1 is 1, right? So for F1, the answer is F1 1 plus 1 is 2, right? So let me store it. These results. Yes. So for 0, the answer is 0. For 1, the answer is 1. For 2, the answer is 2, right? So the answer is 2. Yes. Now do it for 3. What will be the answer for 3? Initially, I stored infinity, because when I got the minimum, I updated, right? For 3, I have to calculate 5, 6, 7, right? Mhm. Yes. So I have to calculate for it 8, I have to calculate it for 9, I have to calculate it for 10, I have to calculate it for 11 also, right? So for 3, calculate for 3, F3. So you can use only coin 1. So it going to be F2 plus 1, which is 2 plus 1 is equals to 3. So I update it with 3. For F4, you are using coin 1 because for 4 also you cannot use 5 and 7, right? So you are using coin 1, and if you are using coin, then next you have to next you are going to construct is F3 plus 1. F3 is 3 plus 1 is 4, right? F3 is 1 plus 1. F3 plus 1 is 4. Now this is interesting. For 5 is interesting. You have to construct 5 because you can use coin 1 or you can use coin 5. If you are using coin 1, then next you have to construct is F5 minus 1. Next you have to construct is F5 minus 5, that is F4, that is F0. So for F0, the answer would be for F4, the answer is 4, and you are using coin 1, so add 1. So ultimately for F5, the answer is 5, right? If you are using coin 1, but you can also use coin 5. You can also use coin 5. So for if you are using coin 5, you have to solve for F0. So for F0, the answer is 0 plus 1. You are going to take only only one coin, right? Similarly, for F6 and F7, F8, F9, calculate it. Yes. Now, for F7, you can take all the three coins. For F8, you can also take all three coins. For F9, you can also take all three coins. For F10, you can also take all three coins. For F11, you can also take all three coins, right? Now, you can take 1, you can take 5, you can take 7, you can take 1, you can take 5, you can take 7, 1, 5, 7, 1, 5, 7, 1, 5, 7. If there are more number of coins in the array, then you can also uh, go further, right? Now, for if you are using 5, F1, so next the problem you are going to solve is F6, and you have to add 1 also because you are using coin, right? Now, if you are using 5, you are going to construct, next the problem you are going to construct is F2 and plus 1 for 5, and for 7, you are going to construct for F0 plus 1. So for this, what will be the answer? F6 is, uh, we not calculate for F6, right? Let's first calculate for F6. For F6, you can calculate like that, F6 minus 5, which is F1 plus 1, F7 minus 6, you cannot use 7, right? Because 7 is greater than 6. So for 1, if you're using coin 1, then you have to construct the next problem is 5. 5 is already solved, which is 1 plus 1 is 2. 1 is 1, 1 plus 1 is 2. So 2 is the possible answer for 6, right? For here, for 6, 2 is the possible answer. So for this, if you're using coin 1, you have to construct 7. Then next you have to construct 6 plus 1, that is 2 plus 1 is equals to 3. Now similarly for this, for F2 plus 1 is 3, F0 plus 1 is 1. So minimum is 1. For 7, the answer is 1, right? So now what can be the answer for F8? 8 minus 1. Next you have to construct for F7. Next you have to construct for F3. Next you have to construct for F1. Now you have to add plus 1 in all of these 5 because you are going to use coin 1, coin 5, coin 7, right? Let me write it clearly. It is very, yes. You have to calculate for F8, right? For F8, there are three options. You can use 8 minus 1. You can use 8 minus 5. You can use 8 minus 7. If you are using coin 1, then next you have to construct is F7 plus 1 because you are using coin 1. F3 plus 1. F1 plus 1. This is 7. 1 plus 1 is 2. F3 is 3. 3 plus 1 is 4. F1 is 1. 1 plus 1 is 2. Right? So the minimum is 2. F3 is 3. 3 plus 1 is. So minimum is 2. For F9, you can use coin 1. You can use coin 5. You can use coin 7. Now you have to 8 plus 1. You have to 4 plus 1. F2 plus 1. Right? So the answer can be here. F8 is 2 plus 1 is 3. F4 is 4 plus 1 is 5. F2 is 2 plus 1 is 3. So the minimum answer is 349. Right? Now, what can be the answer for 10? What can be the answer for 10? For 10, you can use a coin 1, right? So next you are going to construct for F9. then 10 minus 5, 5 plus 1, then 10 minus 7 is 3 plus 1. Now, if you're 9 is 3 plus 1 is 4, 5, 5, 5, 5 is 1 plus 1 is 2, and 3, 3, 3 is 3 plus 1 is 4. So the minimum is 2. Yes, that's the right. You are using coin, 2 coins, that is 5, 5, 4 to construct 10. Now let's do for 11. So for 11, you can use coin 1, you can use coin 5, you can use coin 7. If you are using coin 1, then you have to construct next is 10 plus and plus 1 for the 1, 6 plus 1. Then you have to construct for 11 minus 7 is 4, 4 plus 1. So for this, the answer is going to be f10 plus 1, that is 3. For this, the 6 is 2, 2 plus 1 is 3. For 4, this is going to be 5. So minimum is 3. So that's the answer for 11. So we can, yes, this is DP array that we filled, right? This is DP array. So the answer is DP of x. We filled it from 1 to x, and we further calculated for uh, DP of that sum minus coin that are we using if the sum is less than equal to coin, right? If we can say that if the coin that we are using is less than equal to sum, then we are going to consider this coin. Then we update our DP array by this, right? We have to take the minimum of DP of I, right? We will see that in the code, but you will get the intuition. I hope you got the intuition of what how to solve this problem, right? So let's see the code. So let's see the code. We have a number of coins n, and we have to construct n. Let's take the input coins array, coins of length, and then we have to take input less than n I plus c in coins of I. Okay, now let's define the dp vector. Dp of length x plus 1, initialize with some large number, right? And what we can do is we can initialize our dp of 0 equals to 0. That is the very first problem that we are solving, right? Now traverse int I equals to 1 I less than equal to x I plus plus. Let's take the sum for better understanding, and the sum less than equal to x sum plus plus. And for int coin in coins, now if coin is less than equal to sum, then we are going to consider this coin, or we can say that we can take this coin. Now dp of sum equals to minimum of dp of sum comma dp of sum minus coin, and right, sum minimum dp of sum comma dp of sum minus coin plus 1. If we are taking this coin, then we have to add 1, right? Now we have to print if dp of x is less than 189 plus 7, then we have to print dp of x, otherwise we cannot construct mm, some x, and we have to return minus 1. Okay, so let's have a look. Yes, correct, correct, correct. Yes, here is also correct. If coin is less than equal to sum, minimum degree of sum is 7. Yeah, this is looks good. Let's try it. So we have a number of coins is 3. We have to construct 11 coins are 157, right? Uh, let's try to run it. Yeah, so the number of ways is 3. So that's the code. Okay, what will be the time complexity? The time complexity is the x times into the number of coins. So the time complexity is going to be big of O is n into x into n, x into n, right? So this is the time complexity. We are using the space with dp vector space, that is x plus 1, right? So that's the code. I hope you got this. Thank you.